Hey, everybody. Good morning from Vienna, but good evening or good afternoon wherever in the world you are. Hope everybody's having the most stellar day today. See where people are tuning in from. We got folks tuning in from Zambia, from New Zealand, from Pakistan, from Melbourne, from Germany and Hamburg. I love Hamburg. I've been there several times. From India. Just great to see everyone today. From Nigeria. Love it. Hope everybody's doing well. Welcome to halfway through week 5 of the JavaScript Bootcamp that we're doing in collaboration with Class Central and FreeCodeCamp completely for free. Oh, we got more. Ooh, more folks. Okay, here we go. Australia, Ghana, Nigeria again, Indonesia. God, I just love seeing folks tune in from all over the world. If you're tuning in for the first time, hi, I'm Ramon. We're doing a free JavaScript bootcamp together based on the materials from FreeCodeCamp and enabled by Class Central. If you'd like to sign up, go to classcentral.com. If you want to follow the materials, go to freecodecamp.org. If you want to talk to each other, ask questions, please give answers. Group.classcentral.com. We have a Discord as well. Code of conduct applies for all learners. If you see something you need to report, please do so at bootcamp@class-central.com. So, where else are folks tuning in from? Let's see. We got the US. Oh, it must be so late there. Hope you're getting some rest too. Nigeria, Spain, Tanzania. Love it. Love it. All right, folks. Let's catch up on where we are today. Today, we're going to be doing object-oriented programming. I'm just going to zoom into my screen here. But before I do, just want to catch up on the homework from yesterday. Homework yesterday was to finish off basic algorithm scripting. If there were any that tripped you up or got you stuck, please post those questions in the forum, discuss with one another. I love that this is the opportunity for us to also collaborate with one another as learners. Since there's a lot of folks doing this bootcamp, it's a good idea to be able to also enable your own learning as a dynamic. So today we're going to be doing object-oriented programming, and this is something you might have heard of before. Maybe you haven't. It's all good. Object-oriented programming is let me give my best shot at throwing out a definition, but in essence, it is a way of organizing and programming data so that properties and data can be shared amongst objects with similar structures, right? Say you've got one of the most common ones you'll see is one of cars or animals. Let's go with animals real quick. Right? Animals have a certain amount of attributes. They might have a name, they might have a number of limbs, they might have whether they have a tail or not, whether they can fly or not. And you've seen me do this a little bit when we were doing objects before. But what we're going to be exploring here is how to do, for example, looking more into the keyword this, using prototype chains. That's a little bit new. Constructors, we've seen a little bit when we were doing classes in ES6. And the big one today is going to be inheritance, and I'm quite excited about this. So with all of that said, folks, ask your questions, please. I may answer them, or I might save them for a Q&A that we'll do at the end, at the top of the hour. So don't stress if your question doesn't get answered immediately. It's coming. So let's dive right in. We're going to be creating a basic JavaScript object. On the left, you'll have the instructions. On the right, you'll have the code, and below that, you'll have the console. Now, this we've done before, creating a basic JavaScript object. What do we have here? We have an object called dog, and we have an empty object. So let's dive right into the exercise. Create a dog object with a name and numLegs properties and set them to a string and number respectively. So I like to start, me, by console logging my dog, which is empty at the moment. So we want two properties. One is name. We'll call it Geraldine. And the number of legs will be 4. So nothing we haven't seen before. Name is Geraldine. Number of legs is 4. Happy as Larry. Let's run our tests. Everything is working. We pat ourselves on the back. Pat, pat. And we keep going. Next, we'll be using dot notation to access the properties of an object. Again, nothing we haven't seen before. Print both properties of the dog object to your console. So we got dog with name Spot and numlegs 4. So, okay, console log dog.name Spot console log dog.numlegs. Answer this question by Savarco right away. To create an object, do we have to have a class? Nope. You can see right here. We've created an object called dog with a name and numlegs property. No classes yet. Remember, classes were added in ES6. That is, I think in 2015. So they haven't been added to. So back in the day, JavaScript didn't have classes. We'll see what's going on in just a moment. But good question. Let's run our tests. Everything's looking good. Pat, pat. We keep going. Create a method on an object. So what we can do on objects, let's see, we got dog, name, spot, numlegs 4. And let's see our exercise. Using the dog object, give it a method called sayLegs. The method should return the sentence, this dog has 4 legs. Another question from Zavarko. Is an object like a dict? And I'm going to say that's a dictionary. This question has been asked before, so I'll answer it shortly. Yes, and actually, yes. So if you're curious in other programming languages like Python, you might have dictionaries to define key value pairs. So the comparison is fair. Cool. So we wanted to have a method called sayLegs, and we can see here on the left-hand side how to define a method on a function. It's like a property. That. And when we go to define that function, we have that as we would any other function, and then we return a string. What should this function return? This dog has 4 legs. Okay, this dog has 4 legs. Let's console log that. So call the sayLegs method on the dog, and it returns this dog has 4 legs. Cool. Looks good. Run our tests. Should return the given string. Note the punctuation and spacing matter. Yes, that's correct. I forgot the full stop. Whoops. Let's run our tests again. There we go. Pat, pat. You got to be explicit with these things. Otherwise, things go wrong. So we might see this pop up. Remember that FreeCodeCamp is free and open source. And they're asking for donations. If you've got a couple bucks, absolutely feel free to do so. I'm doing so myself on a different account so that I've got a new account now so that I can have the exercises empty. But yeah, so I'll click on Ask Me Later, and no pressure, please. Make code more reusable with the this keyword. Cool. The last challenge introduced a method a method to the duck object. It used duck.name notation to access the value for the name property within the return statement. The name of this duck is duck.name, and then a full stop. I'm going to take a look at the code here on the right. We've got a dog. It's got a name. It's got a numlegs. It's got a sayLegs that returns this dog has dog.numlegs legs. Let's console log that. This dog has 4 legs. Now, the reason this works is because we have the object dog here that's already been defined, so we can access it from here. But what this exercise is trying to teach us is, what if we have lots of references to dog that change? Remember, this is a let. Let's see what happens if we say dog equals, I don't know, an object, no, a string. Hello. Right? Dog.sayLegs is not a function. We've redefined dog. It just becomes a mess. So what it becomes better to do is instead of referencing the dog directly, let's reference that dog from within itself. This is where the keyword this becomes helpful. Because we're inside a function within the scope of the dog object. So we say, okay, this dog has this .numLegs. So we can access properties that belong to that dog. See, numLegs is a property of dog. So this is a reference for dog. Let's take a look at that a little more concretely. Let's console log this. Take a look. Name spot, numLegs4, sayLegs, and then we've got function sayLegs. So this here is the dog. As Carlos says, it's better to use the const keyword to declare that object. Yeah, that's right. This dog has this .numLegs like. So let's see what our instructions are. Modify the dog sayLegs method to remove any references to dog. Use the duck example for guidance. So that's what we've done here. We've replaced it with this. Let's run our tests. Looks good. Pat, pat. Again, stuff we've seen before, but it's good to keep things concrete. Now we're going to look at something called a constructor. Now, if you've been doing this bootcamp so far, you might recall constructors being a method on a class to initialize that class. So I'll say, let's re-examine class constructors briefly, and then look at these constructors, these other constructors as well. So one at a time. First, we'll do a class. Let's look at an example from before. Animal has a constructor that takes a name. This.name equals name. So const, parrot equals new animal with the name Polly. I console log parrot. We'll see that we've got an object with the name Polly. This we learned back in ES6. And this constructor is in theory pretty similar to what we have here on the left. I would like to copy and paste this, and then we'll take a look at it together briefly. Now, a constructor, you'll see, is a function, and it's capitalized just like a class. Let's see what it does. It is a function that doesn't return anything, and it says this.name equals Albert, this.color equals blue, this.numLegs equals 2. Now, that's what a constructor is. Now, before we look into how to use them, let's follow the instructions in order. So we've got some conventions here. Constructors are defined with a capitalized name to distinguish them from other functions that are not constructors. Cool? Always capitalized. Constructors use the keyword this to set the properties of the object that they will create. Inside the constructor, this refers to the new object it will create. Cool? Rule number 3, constructors define properties and behaviors instead of returning a value as other functions might. Let's look at the instructions. At the exercise. Create a constructor dog with the properties name, color, and numLegs that are set to a string, and a number, respectively. So we'll start from scratch. We want a constructor called dog, function dog, remember capital D, that does this.name equals Fido. Do color, this.color equals Spotty. That's a color, right? This.numLegs equals 4. How about we console log that just for fun? Okay, we see that dog is a function. We're not going to call it yet. We're going to save that for a later exercise. Okay, but we've created the constructor as instructed. Let's run our tests. Still said chocolate for color. That's a better color than spotty. That is at least a color. CPU Cartons is asking, but should this constructor not be defined as inside a class? So as I said before, different constructor. Well, different but similar. You'll see what I mean. Classes were added in ES6. This is how we made blueprints for objects before ES6. Again, we'll get into it. So let's run our tests. Looks good. Pat, pat. Now we will use our constructor to create objects. Again, this is how we could define templates for objects. As Ali says, this is the old school. Now you might be wondering, why are we learning the old school? Trust me, it's good to know some of the old school because classes actually build around this stuff. You're going to see what I mean in just a moment. So, function dog, right? It's got a name Rupert, a color brown, and a numlex 4. Now, if you look here on the left-hand side, to instantiate a constructor, we need to use new and the constructor name, just like a class. Let's do the same for dog. Const dog, new dog. No, let's call it const my dog equals new dog. Okay, so const my dog equals new dog. So console log my dog. So if I console log my new dog, it'll have the name Rupert, the color brown, the numlex 4. Oh, Sil makes a great point. You will sure in any form encounter any form of JavaScript in the wild, old school, and new school. There will be business in legacy code. That's a good point. Thank you, Sil. Now, here's the thing. Now that it's an object, we can change its properties. Hey, name is Leopold, color is brown, numlex 4. Not just that, we can add new properties, as we've done before. My dog bark. We'll make it a function that returns oof. So if I call my dog .bark, it'll print out oof. So that's cool. Use the dog constructor from the last session to create a new instance of dog, assigning it to a variable hound. Okay, so we're almost there. So I want to assign it to a variable called hound. That's it. Let's run our tests. And there we go. Pat, pat. Let's keep going. We can extend constructors to receive arguments. Now, this is interesting. So we can have, for example, let's take a look at the code on the left-hand side. We've got a swan called a new bird, and we're changing its properties. But what if we wanted to do so when instantiating an object from a constructor? This is where arguments will look very similar to constructors we had in ES6 classes. See, function bird takes a name and a color as parameters. And then we can go name this.name equals name, this.color equals color. And we can also just have, hardwired properties like before. So let's take a look at our exercise. Create another dog constructor. This time, set it up to take the parameters name and color and have the property numlex fixed at 4. Then create a new dog saved in the variable terrier. Pass it 2 strings as arguments for the name and color properties. First things first, create another dog constructor. That's already done. This time, set it to take the parameters name and color. See how I'm breaking this down? So we'll just take 2 parameters, name and color. we will set those properties on the object. This.name equals name. This.color equals color. And have the property numLegs fixed at 4. This.numLegs fixed at 4. Then create a new dog and save it in the variable terrier. Okay. Const terrier equals new dog. Now, before we continue, what happens if I don't pass parameters to it? Let's console log our terrier. This will be interesting. Check it out. The name is undefined, the color is undefined, and numLegs is 4. This is because when we don't pass in parameters, JavaScript is like, all right, if you want, they'll be undefined. So if you ever wonder why some of your properties are undefined, make sure you're passing in those arguments. So pass in 2 strings as arguments for the name and color property. So the name will be Terry the terrier. Oh, check it out. See, now the name is Terry, but the color is still undefined. Makes sense. So the second one we need is, I'm gonna copy Sil here and go with the color chocolate. So name is Terry, color is chocolate, numLegs is 4. Pass it 2 strings for the arguments of name and color. I think we're done. Let's run our tests. Yeah, there we go. Pat. Now, we're going to be verifying an object's constructor with an instance of, oh my goodness, Sil, your terrier is called Mocha. That's such a cute name. And Tech Tidbits is asking, I guess default values can be used in constructors. Absolutely, they can. I'll tell you what, I'm going to bookmark this, and then we'll examine it during the Q&A. So let's see. We've got a bird constructor here. This.name equals name. Yep, numLegs and color. Let crow, new bird, Alexis, black, crow instance of bird. This instance of method will return true. If an object is created without using a constructor, instance of will verify that it is not an instance of that constructor. So we've got a canary here that's just an object, and canary instance of bird will return false. And Shoba's asking, what is a constructor? A constructor is a function that creates an object from a template. For example, here's a constructor here. It's called house. It takes as a parameter number of bedrooms. This.number of bedrooms equals number of bedrooms. So a constructor is a function that we can call by saying, let's say, const myHouse equals new house. That's how we call the constructor. And now we pass to it as a parameter the number of bedrooms, 2. Now, what this returns is an object that we store in this variable, house. But let's look at something else. Because not only does it create an object, a constructor will also will store in it the data to tell us that it is an instance of a house. Which then becomes interesting. Your house has more rooms than mine. So my house and your house are both instances of house. However, fake house is just an object with num bedrooms. If I could spell, set to 4. Is fake house an instance of house? No. That's because it was not initialized with the constructor. Bismarck is saying, can we say constructors are functions without return values? I don't think so. And I'll tell you why. Because new house, calling new house, returned a my house. Oh, I like what Sil says. All functions have return values, so that is not true by definition. Exactly. If you have a function that doesn't return, it returns undefined, which is weird. Good point. Zavarko's asking, so house acts like a class? Yes. Up until ES6, classes did not exist in JavaScript. All we talked about were constructors and prototypes. We'll get to prototypes in a bit. Okay? So that's how instance of works. So let's create a new instance of the house constructor, calling it my house. Hey, I guessed what we wanted to do. And passing the number of bedrooms. Then use instance of to verify that it is indeed an instance of house. Let's console log my house instance of house. Notice, by the way, not camel case. Why? Quirks of old JavaScript, I'm afraid to say. But cool. So my house instance of house gives us true. Let's run our tests. There we go. Do a little pat. We keep going. Now we're going to look at own properties. So let's see. Let's take a look at our bird here. Oh, we've got the bird here on the right as well. So it's got this.name equals name, this.numlegs equals 2. And let's take a look at what the instructions are saying. Num and name and numlegs are called own properties because they are defined directly on the instance object. That means that duck and canary each have their own separate copy of these properties. In fact, every instance of bird will have its own copy of these properties. The following code adds all of the own properties of the duck to the array own props. So let's see, we've got an own props array. We loop over the properties in duck. If the duck has that property, it pushes that property into this array, and then we console log own props. This will give us name and num legs. So that's cool. What's our exercise? Add the own properties of canary to the array own props. So we've got a canary called Tweety. We make our own props an empty array. Now we're going to, just like the instructions told us, we'll do a for loop. But Helen's asking, when we may need this? And to that I'll say, bear with me because we're going to see it. Let prop in canary. We'll loop over each of them, and we'll check if the canary has that property. Helen's asking, I mean instance of. And I'm telling, like, trust me, Helen, it'll come up. I promise. We're going to be doing it today, I hope. If not, let's come back to it during the Q&A. But that's bookmarked. So if canary has own property prop, then we'll own props.push prop, and then we'll console log own props. And that's name and numlegs. Something we learned last week, prop in canary should do the same thing. So we can check if prop is in the canary instance, which is cool. But I don't know if that's the same as own prop. We might have to look into that. Let's run our test for now. Looks good. Do a little pat. We keep going. So what are we doing next? Since the numlegs will probably have the same value for all instances of bird, you essentially have duplicated variable numlegs inside each bird instance. 1 second. Got a question for Akachukwu. Can you explain the difference between in and for loops? I did this yesterday during the Q&A, Akachukwu. If you go back on YouTube and go to yesterday's video during the Q&A, I did this I did this answer. I will save this nevertheless for the Q&A. If we don't have any more questions, I'll come back to this, okay? This might not be an issue when there are 2 instances, but imagine if there are millions of instances. That would be a lot of duplicated variable. A better way is to use the prototype of bird. Properties in the prototype are shared amongst all instances of bird. Here's how to add numlegs to the bird prototype. What we call bird, and notice that's the constructor bird dot prototype dot numlegs2. Now, all the instances of bird will have the numlegs property. Okay? Since all instances automatically have the properties on the prototype, think of a prototype as a recipe for creating objects. Note that the prototype for duck and canary is part of the bird constructor as bird.prototype. Nearly every object in JavaScript has a prototype property, which is part of the constructor function that created it. Add a numlegs property to the prototype of dog. And as Savarko says, yeah, it's kind of like class variables. As Carlos would say, let's get weird. Here we go. Prototype time. All right. Here's what happened last time I explained prototypes. I kept saying, mixing up the words property and prototype. That might happen today. I apologize in advance. I will try to catch it. All right. So we've got a function dog. That's a constructor that takes a name as a parameter. It stores the name. We've made a beagle. That's a new dog called Snoopy. Let's console log that. Console log beagle. Snoopy. Now, remember what it said. Nearly every object in JavaScript has a prototype property. Let's check that. What is the prototype of beagle? Prototype. Prototype of beagle is undefined. Okay. What about the prototype of dog? Prototype. Empty object. Okay, that's weird. What about an array? Does an array have a prototype? Prototype. Nope. What about array with a capital A? That it does. So what we can do is let's add a numlegs property to the prototype of dog. So we can do that. Dog.prototype.legs, numlegs. Now let's see what changed. Beagle. If we console log beagle, its own properties include name Snoopy. But does a beagle now have a numlegs? Let's see. What's going on here? Numlegs is a property of beagle, but not an own property of beagle. Numlegs is a prototype of the dog prototype. Dog.prototype. Now look, I added numlegs as a property to the dog prototype, meaning that the dog prototype now has that numlegs. If I were to later on, terrier equals new dog Terry, let's check whether eagle numlegs is equals to terrier.numlegs. It's true. So both beagle and terrier have a numlegs property that is inherited from the prototype. Let's see what Asante is saying. Basically, a prototype on a constructor hides the property for an object instantiated from the constructor. Hold on. The prototype on a constructor hides the property for an object instantiated from the constructor. No sé programar says, what happens if my dog has 3 legs? Well, you can change that. Terrier.numLegs equals 3. Now it's false. Let's do something else. So Beagle's own properties are name. That's the only own property it has. What about Terrier? Now it has name and numLegs. That's because we've given it an own property called numLegs. Nevertheless, Beagle numLegs does have 4 because it comes from the prototype of a dog. As people have been saying, this is where things get weird. Don't worry, this'll click after some time. Let's run our tests. We're good. We've added the numLegs to the prototype. Pat. We might have to go a little bit over time today. Cool. So let's iterate over all properties. You've now seen 2 kinds of properties: own properties and prototype properties. Oh, I'm so sorry. No sé programar. I wasn't trying to discriminate against your dog. Okay, so function bird name. We've got our name. Bird has numLegs 2, and we create a new bird. Cool. That's how we've done it before. But let's look at where things get interesting. In fact, I'm going to start here in the code. We've got a function dog name, this.name equals name. We add the prototype of numLegs as 4. Let Beagle. Oh, I'm so glad you were joking. No sé programar. We got our Beagle set to new dog Snoopy. Now, before I do anything with these arrays, let's console log each of the properties. Let prop in Beagle. And what we're going to do is console log prop. So name and numLegs. Those are the 2 properties in the Beagle, right? There's the name and the numLegs that comes from the prototype. However, as we know, let's see what happens now if we do Beagle has own property. This is where things get interesting. Name is an own property of a Beagle because we defined it in the constructor. However, numLegs was defined on the prototype, which means it is not an own property of a Beagle. However, it is a property. It is a prototype property. Okay? It's weird. Let's try it with the in method as well. What is it? Prop in Beagle. There's the difference. Do you see that? So has own property is different from prop in object. So prop in object will check if it's either an own property or a prototype property. However, Beagle.has own property prop will check only if it's an own property. If it is a prototype property, it will return false. Yeah? Okay, good to know there's a difference. So let's add all of the own properties of Beagle to the array own props. Add all of the prototype properties of dog to the array prototype props. And now we know of a way to distinguish between them. So if Beagle.has own property prop, that means it's an own property, which means we push it to own props. Else, otherwise, it's a prototype property. Prototype props.push. I would like to console log these. console log own props. So own props is name. What about prototype props? Num legs. Cool. That looks like we did it. Let's run our tests. There we go. We do a little pat, and we keep going. Now we've got another thing, another secret property. There is a special constructor property located on the object instances of duck and beagle that were created in the previous challenges. Both of these console log calls will display true in the console. Note that the constructor property is a reference to the constructor function created in the instance. The advantage of the constructor property is that it's possible to check for this property to find out what kind of object it is. Here's an example of how this could be used. So we got a function here to join a bird fraternity candidate. If the candidate's constructor is bird, we return true. Otherwise, we return false. Note, since the constructor property can be overwritten, which will be covered in the next two challenges, it's generally better to use the instance of method to check the type of an object. See? I told you it would come back, Helen. Yeah. So, write a join dog fraternity function that takes a candidate parameter and using the constructor property, return true if the candidate is a dog, otherwise return false. So, let's see. Function dog name, this.name name, join dog fraternity. So const beagle equals new dog. So, console log join dog fraternity eagle. Currently undefined because it doesn't return anything. However, we'll do it if candidate dot constructor equals dog, return true, otherwise return false. So that's true because the constructor of the constructor of the beagle is dog. What's the constructor of an object? Console log ob constructor. So the constructor of an object is the object. The object constructor. So there is a constructor in JavaScript called object with a capital O. And that's what gets used automatically to create an object. Weird. Oh, so what happens if I do this? I'm passing in a empty object. The dog fraternity is not being joined. Now, since this is a comparison, you know what we could do? We could simplify this code to just return candidate constructor is equals to dog. Beagle. Nice. Yeah. There we go. Let's run our tests. Yes, it worked. Pat. Phew. All right, let's keep going. So because the prototype is an object that we can assign properties to, we can also, when, for example, wanting to assign multiple properties to a prototype, right? What we can do instead is assign the prototype as an object wholesale. So instead of assigning one property that we want to change on the prototype one by one. See, I told you I was going to confuse myself. Let me try this again. Instead of wanting to assign multiple properties on the prototype, what we can do is just assign a new prototype like that with all of the prototype's properties in it. So we can assign numlegs, eat, and describe right away as the prototype's properties. English is hard. So what do we want to do in our exercise? We want to add the property numlegs and two methods, eat and describe, to the prototype of dog by setting the prototype to a new object. Let's do that. So we've got a constructor called dog, and we're going to change its prototype to have numlegs set to 4. We will do eat as a function that returns nom, and describe as a method that returns good dog. New dog. Const beagle equals new dog Fred. Let's console log beagle. Its own properties is still just name, but a beagle does have a prototype property of numlegs, 4, of eat, num, and describe, which is good dog. But watch what happens. What if I do it up here before I change the prototype? Beagle describe is not a function. What happened? I made a beagle and I console logged beagle.describe before I changed the prototype. So you need to change the prototype before you can do those things with it from the prototype. Cool. Let's put that back there and run our tests. There we go. We'll do a little pat and keep going. And this is where things get weird. Remember to set the constructor property when changing the prototype. So let's make a, let's const beagle equals new dog Fred. Console log beagle.constructor. It's a function dog, as we would expect. However, let's take that same beagle and console log its constructor after we've changed the prototype of dog. Sorry, I need to create it afterwards. Now look at what happened. After I've changed the dog prototype, even though I can use the dog constructor to create a new dog, its constructor property gets reset. This is one of the stranger parts. This is one of the stranger parts of JavaScript. So even though the beagle was created with the constructor dog, after changing the dog's prototype, the constructor property of any dog that's made after changing its prototype is object, not dog. But it gets weirder. Is a beagle an instance of dog? Yes, of course. We made a beagle with the constructor dog. It's only this constructor property gets reset when you change the prototype. What does this mean? Well, first of all, this is why it recommends using instance of to check the type of an object first. Second, we need to manually set it to a new object. Whenever the prototype is manually set to a new object, remember to define its constructor property, which fortunately isn't so bad. You just put constructor and the name of the constructor. Define the constructor property in the dog prototype. So when we're changing the dog prototype, let's always remember to put in the constructor and set it to dog. Now look, console log beagle constructor. Function is dog again. All is well with the world. This is one of the stranger quirks of JavaScript. And by the way, one of the reasons we have classes in ES6 is that the prototype's object is no longer changeable, which is nice. So let's run our tests. Okay, we survived. Pat. Let's go to the next one. So let's understand where an object's prototype comes from. Just like people inherit genes from their parents, an object inherits its prototype directly from the constructor function that created it. That's what we saw before. Here's the bird constructor creates the duck object. Here's our constructor, here's our object. Duck inherits its prototype from the bird constructor function. You can show this relationship with the isPrototype of method. Let's give that a try. Let's see, we've got a dog, we've got this name, we've made a beagle. So console log dog.prototype isPrototype of beagle. The dog's prototype is the prototype of beagle. True. Is it of an empty object? False. Use isPrototype of to check the prototype of beagle. We just did that. So dog's prototype is the prototype of beagle. True. Let's run our tests. We'll keep going into more of what this means shortly. Pat. It's been so intense, I barely drank water. So let's understand the prototype chain. All objects in JavaScript, with a few exceptions, have a prototype. Also, an object's prototype itself is an object. Oh, yeah, we saw that. Yeah, of course. We assign properties to the prototype. So if it has properties, it's an object. Because a prototype is an object, a prototype can also have its own prototype. In this case, the prototype of bird prototype is Object.prototype. So remember we had that object constructor? We saw that before. Of course, a constructor has a prototype, and the object constructor's prototype is the prototype of the bird prototype. Okay. So how is this useful? You might recall has own property method from a previous challenge. Yeah, okay, yeah, we did. New bird Donald, duck has own property name. The has own property method is defined in Object.prototype, which can be accessed by bird.prototype. Wait, what? The has own property method is defined in Object.prototype, which can be accessed by bird.prototype, which can be accessed by duck. Right. This is an example of the prototype chain. In the prototype chain, bird is the supertype of duck, while duck is the subtype. Folks, this sounds really confusing. We're gonna like take our time and walk through this. Object is a supertype for both bird and duck. Object is a supertype for all objects in JavaScript. Therefore, any object can use the has own property method. Before we look at any of this, I'm just going to comment out this code. So what is prototype? Prototype is an object that is assigned to every object. Which means a prototype. Does a prototype has a prototype? Yes, of course. Because a prototype is an object, a prototype can have its own prototype. So here's what I want to do to explore this relationship a little bit. Before messing around with any of this, let me just. So, because the console, let's do some console logging. Dog.prototype.isPrototype of eagle. True. So the dog's prototype is a prototype of a beagle. That's because the beagle inherits. The beagle's prototype inherits from the dog prototype. Conversely, as we saw before, object prototype dot is prototype of dog dot prototype. So the dog's prototype is a prototype of Beagle. The object prototype is a property of the dog prototype. So if my assumption is correct, object.prototype is the prototype of Beagle. So the dog's prototype is a prototype of Beagle. The object's prototype is a prototype of dog prototype. That means that the object prototype is the prototype of a Beagle. This is called inheritance. The Beagle inherits from the dog. The dog inherits from the object. Ergo, the Beagle inherits from the object. So the hasOwnProperty method is defined in object.prototype. I'll tell you what. Console log object.prototype. I can tell. Oh, look at Yash saying it much better than me. So A equals B and B equals C, hence A equals C. Brilliant. Couldn't have put it any better myself. That means that any methods that are defined in the object prototype, which can be accessed by bird prototype, can be accessed by the duck. Asante is saying object to dog as dog is to Beagle, ergo object to Beagle. This is the inheritance. This is the prototype chain. If you want to read more about this, I suggest doing so on MDN. So what does this mean for us in our exercise? Modify the code to show the correct prototype chain. Oh, okay. Fix the code below so that it evaluates true. Question mark is a prototype of dog prototype. We already know. Object.prototype is a prototype of the dog prototype. Let's run our tests. Looks good. Pat, pat. That's confusing. And now we're going to take advantage of the fact that we know that we can have prototypes of prototypes of prototypes, i.e. a prototype chain, to use inheritance so that you don't repeat yourself. Remember when we were doing the Roman numeral converter, I talked about this principle, don't repeat yourself, or dry. The reason repeated code is a problem is because any change requires fixing code in multiple places. This usually means more work for programmers and ergo more errors. Notice in the example below that the describe method is shared by bird and dog. So let's say we've got two prototypes. Describe is in the bird and describe is in the dog. The describe method is repeated in two places. This code can be edited to follow the dry principle, as is don't repeat yourself, by creating the super type called animal. What does this mean? So we've got an animal, and its prototype has the describe function. Since animal includes the describe method, you can remove it from bird and dog. Constructor dog. The eat method is repeated in both cat and bear. Edit the code in the spirit of dry by removing the eat method, by moving the eat method to the animal super type. So see what we got. We got cat with an eat function. We got a bear with an eat function. And we got an animal with nothing in it. So all we're going to do in this exercise is change the animal prototype to have the eat function in it. Console log nom. The first thing we're going to do is move this function here and remove it from the bear prototype and the cat prototype. Done. all we wanted to do. In the spirit of Dry, by moving the eat method to the animal supertype. Now the eat method is only in one place. Let's run our tests. Looks good. We'll do a pat. And I know it's the top of the hour, but I want to leave you all with a little bit more, a little bit less homework. So in the previous challenge, we created a supertype called animal that defined behaviors shared by all animals. Yash is asking the right question, but how do we connect them? That's what we're doing here. Zavarko is also asking, so where do you define the inheritance in self? Look at y'all reading FreeCodeCamp's mind. So this and the next challenge will cover how to reuse methods of animal inside bird and dog without defining them again. It uses a technique called inheritance. This challenge covers the first step. Make an instance of a supertype or parent. You already know one way to create an instance of an animal is using the new operator. There's some disadvantages when using the syntax for inheritance, which are too complex for the scope of this challenge. Instead, here's an alternative approach without those disadvantages. Wait, what? Object.create prototype creates a new object and sets obj as the new object's prototype. Recall that the prototype is like the recipe for creating an object. By setting the prototype of the animal to the prototype of animal, you are effectively giving an animal instance the same recipe as any other instance of animal. Use Object.create to make two instances of animal named duck and beagle. So before I try and understand what's going on here, I'm going to just follow the instructions. Object.create animal.prototype. Same goes for beagle. Object.create animal prototype. Console log duck. Okay. It doesn't have any own properties. Makes sense. Can I call eat? Duck.eat. Nom nom. Same goes for beagle, right? So we've created two instances of animal, but we're not quite getting there with the inheritance part. We're just creating animals now. What if we wanted to create a bird and a bee and a dog? Let's run our tests, which pass. Pat. We'll submit and go to the next challenge. Set the child's prototype to an instance of the parent. So the first step for inheriting behavior from the supertype, making a new instance of animal. This challenge covers the next step. Set the prototype of the subtype, in this case, bird, to be an instance of animal. Remember that, so if we wanted to set the superclass, we do bird.prototype equals object.create animal.prototype. Remember that the prototype is like the recipe for creating an object. In a way, the recipe for bird now includes the all key ingredients from animal. So when we change the bird's prototype to be an object created from the animal prototype, that means that when we create a new bird, it will have access to the function eat. Duck now inherits all of the animal's properties, including the eat method. Modify the code so that instances of dog inherit from animal. Okay, let's go right into it. So our animal prototype has this. Constructor animal, eat function, console log num num num. We've got our dog constructor. Let's beagle.eat. Beagle.eat is not a function, of course. Dog doesn't inherit from animal yet. But if we call if we set dog's prototype to be equals object.create animal.prototype, now that dog inherits from animal, we can call the function beagle.eat, which inherits from dog which inherits from animal. I want to take this a step further for just a moment to try some console logging. Animal.prototype is prototype of dog.prototype. Now that we've set the animal's prototype to be the prototype of dog, calling animal.prototype is prototype of on dog prototype makes it true. That means that beagle is also an animal. Remember, animal gets its property from object. So beagle is still an object. If we were to look at the inheritance chain now, it would be object to animal to dog to beagle. Let's run our tests. I want to keep going a little bit further, folks. Please bear with me. Pat. We'll get to Q&A in just a moment. So what if we want to reset an inherited constructor property? When an object inherits its prototype from another object, it also inherits the supertype's constructor property. That's interesting. But duck and all in. So we've got a function bird. We set the bird property prototype to be animal. We make a new duck, which is a new bird. And we look up the duck's constructor. Duck and all instances of bird should show that they were constructed by bird and not animal. To do so, you need to manually set the constructor property of bird to the bird object. What does this mean? We've got an animal, we got bird, we got dog. The bird's prototype is an animal, and the dog's prototype is an animal. Let's console log duck.constructor. It's an animal. It should be bird. Eagle, same thing. When we do this inheritance, what we need to do is bird.prototype.constructor equals bird. And same goes for dog. Dog.prototype.cons equals, if I could spell correctly, dog. So when we create this inheritance, we need to also reset the constructor. Just like we did when we changed around the prototype object of a constructor. Fix the code so duck.constructor and beagle constructor return their respective constructors. There's it is for beagle. Let's try it for duck. Fabulous. Let's run our tests. There we go. A little bit of pat. And I will do this one actually. A constructor function that inherits its prototype object from a supertype constructor can still have its own methods in addition to inherited methods. For example, bird is a constructor that inherits its prototype from animal. So we've got an animal, it's got its nom. We've got a bird, and we set it to inherit from animal. We also reset its constructor. But we can also add behavior to it by adding properties to the constructor. For example, we've got fly here, which is a function that says console log I'm flying. Now instances of bird will have both eat and fly functions. Eat comes from the animal prototype, and fly comes from the bird prototype. Cool. So let's see what our exercise is. Add all the necessary code so the dog object inherits from animal. Let's do that first. Okay? Just leave it there. Cool. So we've got an animal prototype with a nom, and we've got a dog constructor. So dog.prototype equals object.create animal.prototype. and dog.prototype.constructor equals dog. Now dog inherits from animal. So far, so good. Then add a bark method to the dog object so that Beagle can both eat and bark. The bark method should print woof to the console. Okay. Then add a bark method to the dog object. Okay. Dog.prototype.bark equals a function. Done. Think of both eat and bark. The bark method should print woof to the console. Console log woof. Let Beagle equals new dog. I want to try it out. Beagle.eat. The nom nom nom. That is inherited from animal. Beagle.bark is woof. I like these sound effects for a 300 kilo dog. Woof. Yeah, it's got to have a real oomph to it. Anyway, sorry. That's done. Cool. Let's run our tests. And that passes. Thank goodness. Pat, pat. And do we stop here? Yes, we will stop here. Folks, this is, in my opinion, one of the weirdest parts of JavaScript. Look how weird it is. I barely drank water. Let's talk homework. I want to take a moment to talk about classes, and then we'll do some Q&A. So homework will be to do the remaining 1, 2, 3, 4, 5 exercises of object-oriented programming. Override inherited methods, mix-ins, closures, immediately invoked function expressions or EFIs, and then using an EFI to create a module. This will be homework for the next time. So again, homework is to do the remaining 5 exercises of object-oriented programming. Tomorrow, we will be doing the 4th project of JavaScript algorithms and data structures, which is telephone number validator. Tomorrow we'll be doing this. If you have the time, and if your brain's like, if you're smarter than me and my brain, because my brain is melted from prototypes, and it's, by the way, super, super, super okay to be really overwhelmed by this because it is a lot. And thank goodness, ES6 has taken great strides to make it easier. I'll show why in just a moment. Have a look at the telephone number validator and start thinking about how you might solve it. Maybe post some solutions on the forums or on Discord and start just giving it some thought. When you're doing the homework, please, if you're stuck, ask for help. Asking for help is really, really good because not only do you invite people to explain things and get better at what they're doing, it also helps you, of course, understand the concepts better. That said, I would like to jump into some code and look at classes again. So let's have a constructor that name equals name, num legs. No, let's do bark equals console log oof. This is a constructor. Let's look at classes again. Okay. We got a dog constructor and an ES6 dog class. Both share the rule that you need to capitalize the first letter. Creating an instance of either is equals to const beagle equals new dog Fred. Const ES6 beagle equals new ES6 dog Fiona. Console log beagle, name Fred bark function. Oh, I forgot to do the, we'll leave it. ES6 beagle, have the name Fiona. Let's add bark so that it's not missing. Console log. Oof. Now, a couple differences you might be seeing already. Where's the bark function? Can I bark as ES6 beagle? You can. However, let's take a moment once again to do to mess around with console log. Oh wait, where'd my dogs go? Yeah. Console log beagle.constructor. Dog. I'm going to take a quick question from Timmy Phil. Must class and constructor start with a capital letter? It is conventional that they do. It's not mandatory, though I would highly recommend doing so. It's how most code bases do it. Console log. Let's take a look at ES6 beagle. Constructor. Okay. So a class is a set of code introduced in ES6 that makes creating constructors a little bit easier. But you're probably thinking, I kind of like the look of the constructor more than the class. It also adds some protections. Let's take a look at their prototypes. Prototype is undefined. So far, so good. Dog.prototype equals, let's just make it an empty object. ES6 dog.prototype, empty object. Look. Cannot assign to read-only property prototype of function ESDog name. This is because classes make prototypes read-only. ES6 knows that you don't want to be messing around with prototypes all too much, and it's like, hey, let me handle the prototypes. You just do your coding. So, what does that mean? What if you want to have inheritance in ES6 classes? Let's again compare how to do that with constructors and how to do that with classes. Let's say the old way and the new way. Let's start with function beagle. Okay. So beagle.prototype equals object.create. How did it go again? Dog.prototype. Yeah. Beagle.constructor equals beagle. Oh, no. Prototype.constructor equals beagle. So now the beagle constructor will inherit from dog. Now let's look at how to do the same, but with ES6. Class ES6 beagle extends dog. We're done. So what does that mean? Let's const beagle equals new beagle with the name Fred, as always. That'll be Fred. Const ES6 beagle equals new ES6 beagle Fiona. Console log beagle. Log ES6 beagle. So the ES6 beagle has inherited all of the functionality from the, oh no, wait, ES6 dog, sorry. There we go. My bad. So class ES6 Beagle extends ES6 dog. Cool. This is how you do inheritance in ES6. This is how you do inheritance in old school JavaScript. This is why we like ES6. And of course, this can go all the way down, huh? Class ES6 Big Beagle extends ES6 Beagle. Now, ES6 Beagle inherits from Big Beagle inherits from ES6 Beagle, which inherits from ES6 Dog. ES6 Big Beagle. What does this mean? First of all, you can't modify. You can't modify the property, the prototype. So, object.prototype.is prototype of. Wait a minute. Hold on. Let's do it better. ES6 Beagle instance of ES6 Big Beagle. ES6 Beagle is an instance of an ES6 Big Beagle. But is it an instance of an ES6 Beagle? Also true. And is it then by extension an instance of ES6 Dog? Also true. Does that mean that ES6 Beagle is an instance of object? True. I want to answer a question from CPU Cortex because I think this is great. ES6 is so much easier. Do we really need the old school? And Sil said it better than I do. You need to encounter it. You need to understand it as you will encounter old code in the wild. You don't need to be a master of it. But understanding a little bit of how it works, I find to be pretty helpful for this reason. Because I remember some of y'all when we were doing ES6 were like, can I just do normal, like old school JavaScript? And I was like, you'll thank me later as to why you won't want to. With all that said, congrats on making it what is, in my opinion, one of the weirdest parts of JavaScript. Let's do some Q&A. Please bring up a question, Galbrush. Is it okay to just appreciate these prototypes and use them instead of the extents you showed a few streams ago? I think so. I think I would recommend taking the time to appreciate prototypes. Because remember, classes and subclasses are a wrapper around the concept of constructors and prototypes. Yeah? So even though we're not directly interacting with it, we're still interacting with it indirectly. Sorry, next question, please. Oh, can we override the eat function in dog? Like if we define eat in dog, which one it would use? It would use the newest one. You absolutely can. And in fact, let me just take a look at the homework for today. I believe you're going to be doing that today. Override inherited methods. Yes, you can. And it will use the newest one. So prototypes can be changed directly. Yes. Yes, we were doing that. Classes block us from changing the prototype. Now you know why, because of all the side effects it has. Any other questions? Do prototypes save space or memory? Compared to what? Sorry, I know I'm being cheeky when I say that, but like, you know, prototypes are the only way we manipulate data in JavaScript. So like, there's nothing to compare it to. You know what I mean? Prototypes are objects. I think one of the, like, you know, you've got your primitive data types like numbers and strings, etc., etc. And then you've got objects, which are kind of like everything else. So it saves you code, if that's what you mean. By, you know, with the dry principle. Next question. Can you explain? Yes. The difference between the in for and the in loop. Yes. Let me just load up a random code base. So const r equals 1, 2, 3. So we've got 4. Let's do both. Actually, 1, hello, 3. So let num of r. We'll just console log. So the for of loop will loop through the members of the array. 1, hello, and 3. The for in loop will loop through the indexes of the array. Why do we want to use an in loop? That's because it's for objects. 1, 2, A. Okay. So for let num in R, let's do for prop in obj. So log prop gives us key 1, key 2, and key A. If we want to do for of on an object, we can't do that because it's not iterable. What about a string? If we go through each letter of the string, we loop through that. What about in? Just like with an array, it gives us the indexes. So that's the difference. Cool. Can you go over the mutations exercise from the homework? I got a bit lost with how best to approach it. Loop, array method, combination of the two. Let's do it. That's from yesterday's homework, right? Mutations. Okay, return true if the string in the first element of the array contains all of the letters of the string in the second element of the array. Okay, for example, hello, hello should return true because all the letters in the second string are present in the first ignoring case. Good to know. The arguments hello and hey should return false because a hello does not return a y. Lastly, alien and line should return true because all of the letters line are present in alien. Okay, first, we got an array. Use spread to assign string 1. Let's call it origin string and target string. Then we want to loop through all letters. No, wait. Make target string, make both strings lowercase. Yeah, that makes sense. Loop through all letters of target string. If letter is not in origin string, return false. Once we've looped through all of the letters, we know that all of the letters are present, so we return true. How I would do it. So let's give it a try. Const origin. No, you know what? I'm going to go with let. Let origin string and target string equals R. And we'll do make both strings lowercase. Origin string equals origin string to lowercase. I'll do the same for target. String equals target string to lowercase. By the way, I see that it's half past. I just want to say we'll do a little bit more Q&A and then we'll call it a day. Cool. Origin string. Okay, loop through all of the letters of the target string. Okay, so for that's a letter of target str. If the letter is not in the origin string, if remember we use index of origin string, index of letter. If it's not, which means if it's equals to -1, and we return, actually I can just uncomment this. Nice. Return false. Otherwise we return true. So we get the origin string and the target string. We make both lowercase. We loop through the letters. If that letter is not in the origin string, we return false. Once we've looped all of them, that means that none of them have returned false, which means we can return true. Let's give it a try. This one should give us false. Yeah. What about he? This is true. Looks good. Let's run our tests. There we go. Pat, pat. Hope that makes sense. Genericable. Cool. Oh, there's a lot of chatter. I love it. Is the runtime of an ES6 arrow function faster than a normal function? I have no idea. No, I have no idea. That's a good question. Are arrow functions faster than? Are arrow functions faster? JavaScript. Are there let's see that you're not the only person to wonder. Are there performance gains in using the ES6 arrow functions? Does not put any preconditions for either to be faster, so it's totally up to the implementation. I think this is a great answer. Let's go over what that means. You see, ES6 is a standard. That is, we're saying like, this is how ES6 functions should work. But what happens? JavaScript is a standard that then goes and becomes implemented on different browsers. Believe it or not, JavaScript in Firefox is slightly different from JavaScript in Chrome, which is slightly different from JavaScript in Safari, depending on the implementation. There is a set of rules that lots of very clever people come together and call a standard, where they say, this is how you define a variable in JavaScript. This is how you define a function. This is how you do ES6. This is how you do blah, 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 and so on and so forth. Right? Now, how that's implemented, how the internals of how that's done is up to the browser vendors. So maybe they're slightly faster in Safari. It depends on the browser. It's a good question. Cool. Any other ones? Can we also do the chunky monkey exercise from yesterday's homework? Of course. Let's look at algorithms. Chunky monkey. Write a function that splits an array into groups the size of the length of size and returns them as a two-dimensional. Okay. So that means that, for example, chunk array in groups A, B, C, D would be split into groups of 2. Okay. How would I do that? Let's give it a try. First, we'll declare empty array. Yeah. Loop through R. No, actually, declare empty result array. Declare empty row array as well. We'll loop through the R. If index of element modulo there. If the remainder of dividing the index of the element by size is equals to 0, make a new row. Oh, hold on. Declare empty row array and push it to. Declare empty row array and push it to. Declare and push it to result. Make a new row array and push it to result. Push element to row array. Cool. I'll do it this way. Some folks are giving suggestions on other ways to do it. But I want to try it this way first. So loop through array, return result array. So result equals empty array. Let row equals empty array. Row result dot push row. Loop through R. Okay, for, and I'm gonna need the index. Let I equals 0. I is smaller than R dot length. I plus plus. If the index of the elements, so if I modulo size is equals to 0, new row array and push it to the result array. Row equals new array, result dot push row, push element to row array. This is row dot push R at I and result. Let's give that a try. That didn't quite work. That's because we're starting at 0. So what if instead I cheat and I don't push that first one? That does it. A and B, C and D. Let's try it with other size groups. Yeah. Nice. Okay, that works. Cool. Let's run the tests. There we go. A little bit of a pat. Hope that helps. Michael, I want to say if you don't have to declare an empty row array, keep pushing slice and I plus size. That sounds good. I would say post that solution into the forums or into the forums or into the Discord, because we are out of time now. I don't think we have any more questions. So I just want to say, again, congrats on making it through object-oriented programming. Just a quick reminder about the homework. So basically, your homework is to finish object-oriented programming. Tomorrow, we will do telephone number validator, the project. So start having a look at it as well. If you're stressed for time, may I recommend you don't need to have finished basic. You don't need to have finished object-oriented programming in order to do telephone number validator, because as null3 says, it is going to be a regex moment. Yeah, it's going to be okay, folks. I promise. Again, tomorrow I'm going to show you my solution, how I derive the solution. It's not the best one. It's not the most efficient one. Also bring your solutions and let's explore them. Okay? Well, I would say with that, we can call it a day. I'll just say thank you so much for joining today. It was lovely as always. Thank you for asking such good questions and challenging the norm. And I will say, just have the best rest of your day. Take care, everyone, and see you next time. Bye-bye.